Yeah, good morning, students. In the previous class, we had a discussion on two-dimensional array initialization. Now, today we would like to discuss regarding this one of the important applications of these one-dimensional arrays is searching. So, more specifically, we have two different types of searching techniques. One is call it as a linear search, or also call it as a sequential search, and another one is call it as a binary search. So in this particular video, we would like to discuss about the linear search technique. And we also have this linear search technique in our curricula. So binary search technique we will discuss in the next semester, that is data structures using C. Fine. So now I would like to share my screen. So linear search technique. So the objective of this today's session is that this session will develop the students' knowledge on searching an element in a given array of elements. Outcome of this session is that after the completion of the session, students will be able to develop the code in C language to implement this linear or sequential search. So what is meant by a linear or sequential search? So the linear search is defined as a sequential search algorithm. So that starts at one end and goes to each element of a list until the desired element is found. Otherwise, the search continues till the end of the data set, and it is the easiest searching algorithm. So just we had the two important search methods, which are called it as linear search and then binary search. So here we will discuss about the most popular search technique, which is called as a sequential search or a linear search algorithm. So it is the simplest searching algorithm. In linear search, we simply traverse the list completely and match each element of the list with the item whose location is to be found. If the match is found, then the location of the item is returned. Otherwise, the algorithm will return that a null or the search is unsuccessful. So it is widely used search from where the unordered list is given, that is the list in which the items are not in sorted order. So the time complexity of this linear search is order of n. The worst and average case time complexity is big O of n. So the working of this linear search is shown in this particular example. To understand how the linear search will works, let us consider these are the elements given in the array. So 70, 40, 30, 11, 57 and so on. So these are the 9 elements given in the array. Now let us assume that the element to be searched is k equal to 41. So now we start from the first location and compare whether the k is equal to 41. So is k is equal to 41? No, k not equal to 70. The value of k, that is 41, is not matched with the first element of the array. So we move to the next element. So we will move to the next element and follow the same procedure. So is a of 0th first location is equal to 41? No. So like this, we will continue this process. So k is not equal to 40. Okay, so is k equal to 30? No. Is k equal to 11? No. Is k equal to 57? No. Is k equal to 41? Yes. So the search is successful here. Now the element is found at this index location. The index location is 5. At the fifth index location, the search element is found. So this is how we are sequentially searching. Okay, first 0th location element, then first location, and then third location, and then fourth. Like that, we are searching the elements sequentially one after another. So that is the reason it is called it as a sequential search or a linear search. So the steps or the algorithmic steps which are used in implementation of the linear search are given below. So first we have to traverse the array elements using a for loop. In each iteration of the for loop, compare the search element with the current array element. And if the element matches, then return the index of the corresponding array element. If the element does not match, then move to the next element. So if there are no match or the search element is not present in the given array, then print search is not successful. So this is what we are calling it as the algorithmic steps. Now coming to this is a C program for implementation of this linear search. Now we are asking the user to enter number of elements in the array n, and then we are asking the user to enter n elements c equals 0, c less than n, c plus plus, scanf percentage d ampersand array of c. So we are reading this particular loop is used for reading of the elements into the array. Fine. And then next we are asking the user to enter the element to search. So which element do you want to search into this search variable? Now for I equal for c equal to 0, c less than n, c plus plus. If ARR array of c is equal to search, so that is if required element is found, then print the search element is found at location c plus 1 location, and then we are coming out of the loop. So this is what the break we are using here. So if search is not successful, how we will know that search is not successful? Until the c value equal to n. So that means we have reached to the end of the array. Once you reach to the end of the array, we are not able to find an element. Then we are comparing here. If c equal to n, the search element is not present in the array. So this is a program which demonstrate the linear search technique. Fine. So now the reflection spot is that where is linear search used? Anyone will have idea when the list has only few elements, when performing a single search in in an unordered list used all the times, when the list has only few elements, and when performing a single search in an unordered list. So what is the right answer? Where is the linear search used? So the linear search is useful when we have very few elements in the array, and also the array need not be a sorted array. So that is unordered list of elements, and we are performing a single search in an unordered list. Then we are making use of a linear search. So answer is D. So the lecture outcomes after completion of this session, the students will able to develop the code in C language to implement this linear search. So summary of the session is that linear search in C is to find whether a number key element is present in the array or not. If it presents, then at what location it will present, it will returns that location. Otherwise, it will specifies that the element is not found. So it is also known it as a sequential search. So it is a straightforward and method which is used for performing the searching operation. We compare each element with the element to search until we find it or the list will ends. So the time required for searching in the best case is order of 1. That is at the beginning of the list itself. In the worst case and average case, its time complexity is big O of n. So this is a lecture level practice problem. Develop a C program to print all locations at which required element is found, and also the number of times it occurs in the array of elements. So this is a multiple occurrences may be present. So how many different locations that element is present. So this is an extension for your linear search technique what we discussed now. So thank you one and all.